I'm recording now. Okay. Okay, so 1A, we talked about logical fallacies, and 1B, we talked about propositions. We talked about ways to connect propositions. So going back, the first week we just had an introduction, right? And then the second week we had 1A and 1B is what we went through. So 1A was all about logical fallacies. So we went over that first day. We went over a lesson. And then 1B was about propositions. So propositions are things that are either sort of true or false. They're verifiably either true or false. So we can give them a true or false quality to them. And then we can connect them, right? Was the other part of that lesson. Was like there's the ands, the ors, which could be inclusive or exclusive. But we typically just assume it's inclusive unless we're told otherwise. And then this is section 1C, so we're starting to talk about Venn diagrams and sets. So I got this crazy picture up here. I think this is like a 12-set Venn diagram or something crazy. Any questions about anything we've done so far about what's expected? I believe I got section 1A graded. I will get 1B graded pretty shortly. That's all y'all have submitted so far, I believe. But 1A should be graded. So hopefully, if you have something that is graded, you're going back and looking at that and seeing what you might have got right or wrong on your assignment. I make notes on those assignments, so I spend time to make the notes. Please spend a little bit of time to read them. I'm not making them for myself, you know. Where are we at? All right, so if you're joining in now, make sure it's available to everyone in the chat. You can always link up later. Okay, so I think I'm going to get started with this. It's already 3:07. Come on. Ooh, did I join? Let me hit this timer. Decide whether each of the following statements makes sense or is clearly true or does not make sense is clearly false, and explain your reasoning. So I think this is just true or false. What was the code? 582-701. I am student number 1. How many? 21 people? There's 24 people here in class, which means 3 people have fallen asleep. And we haven't even started. Oh, man. And, like, I mean, it's really easy to do nothing in this class, if I'm being honest. Like, you can do that if you want. But then when you're not passing and you're like, why am I passing? I'm going to start pulling stuff up like this. Like, hey, you didn't log in and you weren't active in class this day. So, like, how do you expect to pass if you're not going to be active? I don't understand. So, I guess I need to answer this too. Huh? Decide whether each of the following statements makes sense or is clearly true or false. The people who live in Chicago form a subset of those who rent apartments in Chicago. So most people have answered, except for me. So what is a subset? So if you were to describe or explain what a subset looks like, what would you say? And I know there's like the book definition. I guess you can give me that.
It's like a group that's a division of the first group.
Yeah, so it's a group. It's a smaller group, right? And it's contained. It's contained all within the other group. So everything within the first group should also be in the first. So is it true that the people that live in Chicago form a subset? of those that rent apartments in Chicago, and this is maybe it's a little bit weird, oddly worded for like the first problem, but is that true? Let's see. I think it's about to shift. Is it? Does it automatically, doesn't it? Nope. Come on. It should tell me. What do we get? Yeah, it's a bit oddly worded. So it's false. Let's explain why it's false. The people who live in Chicago form a subset of those who rent apartments in Chicago. Why would that be false?
Because not everybody lives in apartments in Chicago.
Yeah, and I think like the easy way to fix it is just to flip those two words, right? The people who rent apartments form a subset of the people that live in Chicago. So they kind of have it flipped from like what they maybe should have it is one way to look at it. And then another way to look at it is that there's other people that live in Chicago that don't rent apartments. So yeah. The people that live in Chicago, they form a subset maybe of like the people that live in Illinois. But the ones that rent apartments are the smaller set. The people overall that live in Chicago are the larger set that contains all the people that live in the apartments. So the people in the apartment should be the subset of the people that live in Chicago. So I know that is just like, I know the other class did not do on that one either. But like I hope going over it and getting a little bit of an explanation, it makes you stop and realize why it's false, right? Does anybody have any questions about why that's false? Okay. All right, so now what are they saying? I counted an irrational number of students in my statistics class. Does that make sense? Can you count an irrational number of students?
No.
Maybe. Who knows? I guess we'll know in a second when everyone answers. What is an irrational number? Anybody got an example? I know it's coming out. Where is it at?
Pi.
There we go. Yeah, pi is always like kind of the first one. It's like 3.14 something, 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 something. Doesn't stop, doesn't repeat. There's no repeating pattern. Can you count an irrational number of students if you're counting fractional numbers of students? I don't know. This isn't a biblical tell. We're not splitting people in half.
No, you cannot split people in half.
I mean, you can, but we're just not going to do it in this class. For all intents and purposes, it's not usually the applicable.
It just wouldn't be practical.
Yeah, it's kind of messy. So this does not make sense. We cannot count like fractional numbers of students. And even then, like doing an irrational number, right? That never ends, never repeats. So are you taking too much or are you taking too little when you take a fractional amount? I don't know. It's in between the two. Yeah. What else is an irrational number? I think we'll get more examples later. That's right. We have that little game later. Things like root 2, root 3, anything that's like a square root of a prime number, it's going to give you also like an irrational. It's not going to factor out of that square root. The other thing was like Euler's number, right? Which I think we'll talk about that when we do finances. Yeah, we definitely do. So Euler's constant. Okay, so now we're classifying numbers. I knew this was coming up. This is number 13. The number is 888. So I made a mistake when I read this. And like it looked like a decimal to me almost. But we're starting with the smaller set and kind of working our way up there. So the natural numbers, those are like your counting numbers, your whole numbers. That's where we start introducing 0 The integers is where we start introducing the negative numbers. The rational numbers is where we start introducing fractions. So those things either terminate or they have a certain pattern, right? Rational numbers, as a consequence of them being able to be written as a ratio, they either have a terminating or pattern. And then outside of that, we have real numbers, which includes both rational and irrationals. So we want the smallest set that this is contained in. So as far up as you can go here. Man, I think this might be stuck. Are y'all answering?
I answered. I don't know what's going on.
Yeah, I think it's lagging. They want me to pay for stuff, probably is what it is. Trying to squeeze that turnip. Oh yeah, natural numbers. I think 11 people said that. Oh, okay. A whole number. So where are we going? It's definitely a real number, right? 888 is definitely a real number. We could say it's definitely a rational number, and maybe it's not written as a ratio, right? But if we have 888, if we have a number like that, what can we always write it over? So it might be a weird question. If we want to write a whole number as a fraction, we can always write it over 1. So if we do 888 over 1, like all the whole numbers basically fall into here, right? So it is definitely a rational number, even though it maybe doesn't look like it. It is an integer. It is a whole number, but it is also a natural number, right? So this is the smallest one that it fits in. So your natural numbers are your counting numbers. They're like 1, 2, 3, 4, all the positive whole numbers, things that you would count with, right? It's your counting numbers. Questions? I think most people are getting it. Most people are around here. You said at least a whole number. You can go like one step further, basically. Is it making sense? Let's see if they got something. I'm sure there's this one I think is pretty good. Ours separates the 0 though. So the whole numbers are a separate set. So this might be a good thing to note too, right? Some books do their sets a little bit differently. They will include 0 in their natural numbers. I don't like to do that personally, and I don't think our book likes to do it either. So this might be a better one to pull up. But this is what the sets sort of look like. The smallest set is the natural numbers, the counting numbers like 1, 2, 3. The next thing to get to the whole numbers, we're adding 0. So the whole numbers look like 0, 1, 2, and 3. The integers, we start throwing in our negative numbers. Rational numbers, we start throwing in things that look like ratios, look like decimals that terminate or have a pattern. And then outside of that's the irrational numbers. And if we look at the whole thing, that's the real numbers. So I'm hoping this is the sort of picture you have going on in your head, hopefully. And so we want to determine the smallest set that it fits in. And with that, let's get to the next guy. So where are we at? 15 is 3/4. So we're looking along there, seeing where it fits in first. Is there one more? There we go. Nice. Nice. So 3/4 is a ratio. It is a rational number. It is not going to fit in under, move. It's not going to fit in under natural numbers. It's not going to fit in under what? Whole numbers. It is not an integer. Integers would just be like negative whole numbers. It is a ratio. It's going to fit in under here. This is a little too general, too vague. Okay. I think we get one more number, huh? What are we getting now? Pi. Oh, man. Find where along those sets that's going to fit. There's not really a lot of options for this one, I don't think. I think there's basically one thing you could tell me. Everything else, I think, is pretty much going to be incorrect. There's one person. You have the power. There we go. Yeah. All right. So pi is irrational. So if you tell me it's rational, it is definitely not rational. And if it's not rational, it's not going to be any of these other ones. So I think most people are getting that. There's a few people that are still off. But it is irrational. It goes on forever. You cannot write pi as a ratio, right? There's no way to write it as a ratio. It's one of the things you have to prove. Well, not for pi, but for root 2, I think it's one of the things that like they make you prove in one of your introductions to proofs class. Usually, square root of 2 is irrational. All right, cut that time. What does it say now? Okay, so this is going to be very sort of particular with how they probably want their inputs. So use set notation. So you need to use the braces. You need to find the braces. You need to know what the braces look like. And for the longest time, I had to the hardest time differentiating between braces, brackets, and parentheses. What are we writing? Is this the one with the dates of July? And then the other thing is you need to know how many days there are in July. So do you know how many days there are in July?
Is it 31?
There are 31 days in July. Do y'all know this trick?
Yeah, the knuckle trick.
Hey, chill. No. Yeah, is there a dog out there? Do you want to go get that dog? Do you want me to go get that dog? All right.
Yeah, I was doing that. I was like,
Sorry.
wait a minute.
Yeah, sorry. So if you do the little knuckle trick, can you see that picture? You can see this
Yes.
picture, right? Yeah, there you go. All the ones that are on humps, if you keep counting the humps and the dips, each one's a month, and the ones that are on a hump have 31 days. Each one that are on a little divot have 30 days, except for February, who's a little freak that's got to have 28 days.
Yeah.
Sometimes 29. Everyone, it's once every 4 years, you know.
Leap year. Yeah, leap year.
Yeah. Okay. So what were we doing again? Okay, so then we want to write the days in July. Someone was writing the dates, which I guess is also a valid thing to do. But they're just wanting the number of the day, if that makes a little more sense. So I think the format is you write the braces, you write the number, you write a comma, and you typically do a single space after your number. You should really do 2 to 3 numbers to get a pattern. It should probably be 3.
So do we write all the way to 31?
Yeah, but you can use the ellipses, the 3 dots, if you want to indicate a pattern. So if you wanted to write out like maybe like 2 or 3 numbers and then do an ellipses and then write out 2 or 3 of the last numbers and then close your braces off. It's going to be probably really particular on like formatting. Oh, which reminds me, what I did in my other classes, I just put up a Word document. It worked really good. Let's do it. Blankety blank blank. And I try to put it in a few different ways to hopefully catch if you're doing it a little bit different. But again, it's like one of those things. It's a computer, and I have to put in like all the all the acceptable answers or whatever. I have to try to predict what you may or may not do. It can be a bit difficult. Lost connection again. All right, let me refresh this. All right, so hopefully you're finishing up typing whatever you're typing. Getting your response in there. Have to figure out where the brace symbol on your phone is. How many slides are this? Who's talking? Brackets or braces? Should be braces. Right? Braces are these little curly ones. Brackets are the square brackets. Parentheses are the curvy ones. Braces kind of look like the braces that go on your teeth. That's kind of how I remember it. Yeah. All right, so I'm about to hit it. Where are we at? One more person. All right, so it looks like 2 people got it. So I said to use like 2 or 3 numbers. So let me share like what share what I'm kind of expecting on this one. You share in a Word document. So let's see. You should be able to see this Word document, hopefully. So the important thing if you're doing a set is that you have braces. For every set, we use the braces to indicate that it is a set. And now we're doing the dates in July. So if we do something like 1, 2, 3, and it's probably going to be really particular about spacing. What am I at? 29, 30, 31, sorry. And so this should be your response. And I said use like 2 or 3 numbers to indicate a pattern. So I guess we could have took off maybe like a number there. Maybe a number here. Right. You should probably really have 3 numbers to indicate the pattern, if I'm being honest. But this isn't a super complicated pattern. So. If we write it out all out, it's literally every number between what 1 and 31. Are there any questions about what this set should look like? So why? Where were y'all going? Was it like a formatting thing? Like what's throwing y'all off on that one? I guess is my question.
I think the wording just threw me off. I didn't fully understand.
Okay. Let's see the correct responses. Is this what they have? Oh yeah. Okay. Yeah. Ooh. So the problem with this is we don't know where to end, right? If you just have an ellipses and you don't tell me where to stop. So that one looks pretty good. I think that might just be for oh, never mind. That was the one that's correct. Yeah, I mean, most of them look like you're getting the concept. It looks like a sort of like most of this is just formatting sort of stuff. There's someone did, yeah. So ooh, there you go, gold star. I'm glad someone did this because I didn't want to do it. This would be like every number between there, right? So this would be good. That's great. So I don't know why I didn't count that correct. It definitely should have. All right, so I think that looks pretty good. Most people, I think, even if you're not getting it correct, it's the small things, right? I think you're getting the concept. It's more of just the sort of like the conventional notation sort of thing that's happening, right? Perfect squares between 10 and 40. So what are perfect squares? What's the first perfect square? Oh, yeah. Who's chatting? 16? 16 is a little high. 16 would be what? 4 and 4? 4 would be the first one. That's 2 and 2. So we start off with 2 squared. 2 squared is going to give me 4. 3 squared is going to give me 9. 4 squared is going to give me 16. 5 squared is going to give me 25. So I'm starting out I guess technically we should probably start out with 1 and 1 squared, right? But a perfect square is just you're squaring one number.
Well, it says between 10 and 40.
Yeah, so we want to go between 10 and 40. So if I'm thinking about perfect squares, 2 squared is going to give me 4. 3 squared is going to give me 9. Let me think.
4 and 4, 16.
4 and 4 will give me 16. I'm trying to go really slow for some reason. 5 and 5 will give me 25. 6 and 6 will give me 36. 7 and 7 will give me 49. So I think I said something out loud there. Who knows? Will I get it right? Did I do it correctly? Oh, I might have. I think I did. So what are we going? 4, 9, 16, 25, 36, 49, 81. Oh, 64, 81. I missed one in there. Okay, so we're doing perfect squares between what, 10 and 40. Perfect squares are things that are being squared, like 2 squared is what, 4. 4, 9, 16, 25, 36, 49, 64, 81. The other thing, when you're writing a set, typically you want to write things like least to greatest, right? Smallest number to the largest number. Some sort of pattern, usually. If not, that's kind of the default pattern that we go to, right? How many people? 6 people? Is it still up to date? All right. I'll give you another minute. It shouldn't be that long for this one, though. All right, looks like some people are getting it. Where are we at? 5 people away. Hope I got it. I think I might have put an extra number in mine, to be honest. Oh, Oh man, come on. What are y'all doing? There's like 3 numbers you should be putting in. Did I put an extra number in? I guess I did. Whoops. All right, so the correct response should be 16, 25, and 36. Those are the 3 perfect squares that are between 10 and 40. Any questions about this? Why that's the solution? What are we looking at? I think some people, oh, you left off like a 1 or something there. I don't know what you're doing. 16, 25, 36. I'm seeing quite a few that say that. 4, 5, 6 would be the thing before it got squared. So I know where that's coming from. But they want the perfect square, which would be the 16, 25, and 36. Questions about this one? Man, y'all are quiet. Some of y'all are getting it. Some of y'all, I don't know. Okay. So we want to draw a Venn diagram for this set. Provide an explanation of the diagram you drew. So if you were to describe what the set looks like, is this going to be, I think there's basically 3 sort of pictures, right? They're either overlapping or they're disjoint, or one is a subset of the other. So if you were to draw this, teachers and women, what would this look like as a Venn diagram? Some chat. Overlapping subsets. So I know, like, first off, they're not disjoint, right? There are teachers that are women. There is some overlap there. There are women teachers. The other thing is this a subset? Are all teachers women or are all women teachers? If they were subsets, you would be able to say one of those things. So all teachers are women is not true because there are male teachers, right? All women are teachers is true because there are women out there that don't go into the education system to teach. So how should these look? I think I kind of narrowed it down, right? They're not disjoint. They're not subsets, although I think that's a lot closer than saying disjoint. They are overlapping. So these should look like 2 overlapping sets. And again, if you had like subsets, right, you would have like 1, 2, 3 different areas, and if you had subsets. But if we have overlapping sets, it's giving us 1, 2, 3, 4 different areas. So it actually gives us more sets. There's things outside of here and there's things outside of here. Having a subset is like you kind of delete the outside part, kind of, sort of. So neither is a subset of the other. That's an important thing to probably realize. And then the other thing is that they do have some overlap, right? They're not disjoint. All right, thinking about those 3 pictures, I think we have another thing. Teenagers and octogenarians. So how are you going to do this? Octogenarians are people in their 80s. What is that? What is the Venn diagram for this set going to look like? Will it be overlapping, disjoint? Someone said disjoint. Anybody else got a response? I got another disjoint, got 2 disjoints. I think that's pretty good. Dude, I got a third one. Woo, got 3 disjoints. Speak now or forever hold your peace. There's never going to be someone, some Benjamin Button guy or something that's like, I'm both an octogenarian and a teenager. I don't know. I want to think of someone that's like, yeah. There's no overlap here, right? No Benjamin Buttons. So they're definitely disjoint sets. You're not going to be both in your teens and both in your 80s. Those are things that do not happen simultaneously. They should be separate. Questions about this? Don't draw them bubbles together. It does not make sense. Where are we at? Oh, point by point. So this is the diagram. We're going to use this diagram. We're going to look at a few questions about this Venn diagram. We're going to pull numbers out of here. So if we're looking within the blue, that's going to give you men. If we're looking within the red, this is going to be people under the age of 30. And so if we look here, we got 4 different spots. So this is men that are over the age of 30. This is men that are under the age of 30. This is people that are not men. So this is women that are under the age of 30. This is people that are women who are over the age of 30. So now they're going to ask us a few questions. How many people at the party are under 30? So I think I have all the questions on this page. So I want you to think about these questions for a minute as I go through them, and then we will answer them like piece by piece. I think they're broken apart a little bit. Yeah. Next one, part B says it's frozen is what it's saying. Man, they are really want me to like pay for this stuff or something, I think. All right, let's see if we can go through them now. B says, how many women at the party are not under 30? How many men are at the party? And how many people are at the party? So for some of these, we might have to add some of those sections together. And if I remember how I did this correctly, I think I can go to the next one and I can ask the question and then I can see who has a response. So how many people at the party are under age 30? And if you don't want to add numbers, you can just tell me what numbers to add and like I will add them for you. I don't care. I just want to make sure we're pulling the right numbers out of there. Gotta look in your chat. All right. I got one person saying 31. I got another person saying 31. And got a few people saying 16. Ooh, I like this. 16, 31. Which one is it? Anyone want to chime in? I feel like I'm getting more. Okay. All right, so if we're looking at people under 30, we see 16 and we see 15 within the circle. So some people are telling me 16. That is half of them. So you still have to grab this 15 over here. So it should be 16 and 15. Where are we at? Should give me 31. I think most people seem like they're giving me 31. There were a few people that pulled the 16. So I'm glad, like, y'all, oh man. I know in reality, when you get things wrong, there's usually bad consequences for it. There's not in this class. I will get super happy. Like, I'm glad when you tell me stuff that is wrong. Because if you have a question or if you're getting something wrong, I guarantee you like at least 10 other people have that same thought in their brain and they're just not like, they just don't want to say it out loud. So it's great whenever y'all say stuff that's wrong. I get really excited. I love to hear wrong stuff during homework.
Last semester, when my teacher brought up the Venn diagram thing, this was the only thing I was good at. So the minute I saw that, I was like, yes! Finally, something I shine in.
All right. That's the basis of math right there, set theory. Oh yeah, and in the next section, we're going to start using these to start analyzing arguments. If you can do this, then you can also, hopefully you can be good at analyzing arguments. So this one, I think this one is a little more maybe straightforward if I remember correctly. How many women at the party are not under 30? Not under 30 would also be like saying they are over the age of 30. And so this one, it might take you a second to think about what they're asking. There's a few people telling me I think they're correct answers. Anybody else want to chime in? I don't know where you're getting that number from. I don't even see that number on here. Okay. There's a few people. So women tells me something about this set right here, right? So what women tells me is I do not want to be within the blue circle. So I'm already outside of the blue circle. So if I'm outside of the blue circle, then I'm looking here and here. Just by that word women, I know I'm outside of the blue circle. And then the next thing I see are not under 30. So if I'm going in here, these are under 30. These would be the ones that are not under 30. So this is just basically, it's giving me a description of one of these spaces, and it's giving me this description of, the wrong button. That space right there that says 28. It's telling me it's not in this circle. It says woman, and then not under 30 tells me it's not in this circle. And the book likes to reinforce binaries. I don't know what to tell you on that. If it's not a man, it's a woman. How many men are at the party? I see 22 and I see 37 so far. 37. Seeing a lot of 37s. All right, so if we're looking at men, I think that guy, I don't know that guy. I think that person might have corrected their solution too. Okay, so this says men. If we want to look at men, we want to look at the blue circle. What we have to do is we have to look at everything in this blue circle. So we're looking at everything in here is both the 22 and the 15. So if you give me 22, you're only giving me men that are above 30. We also want men that are below 30. We want both of those men. Next one. How many people are at the party? Y'all actually added all that together? Okay. What am I adding together? How many numbers I got to add together here? Y'all are actually doing it. I figured y'all just be lazy and tell me. Add all the numbers together and you should get 81 is what people are getting, I believe. They want to know everyone that's at the party, man, woman, above, below 30. Doesn't matter. We need a head count. We're adding all four of those different groups together. It's 81. And I talked a little bit about this, like there's 4 sections here. And I think if we get to 3, we get what, 8 sections, I believe. Another way to think about that is it's either in or out of the circle. So for each circle, you have basically 2 options that you're creating, right? 2 times 2 will give me 4. There's 4 different spots here. So that counting principle comes up again with these things. 3, 6, 7. There's 7 spots here, huh? All right, so we got 4 more questions. Now we're increasing things a little bit. We're doing 3 circles. So now we got a 3-circle Venn diagram. So this is women. This is what? Women with a college degree who are not employed. This is people that are not women. So this is men with a college degree who are not employed. This is people with a college degree who are employed. This is people who are employed that don't have a college degree and are men. This one would be what? People that are women that are employed. This one would be women that are employed and have a college degree. All 3 of them. This one would be no 3 of them. So this would be men without a college degree who are unemployed. Good boyfriend material. All right, so how many people at the conference are employed men with a college degree? How many people at the conference are unemployed women? How many people at the conference are employed women without a college degree? And how many women are at the conference? Okay. So how many people at the conference are employed men with a college degree? So I think this is asking me for a specific spot. There we go. So I want to go by this like a little bit piece by piece. If it's employed, it has to be within the white circle. If it's men, it cannot be within the blue circle. So it's got to be within the white, but outside the blue. So I think that's already giving us probably between these 2 numbers. And then it says they have a college degree. So it should also be in the red circle. So I believe the number we're looking for here is that 16 that's hitting right there. And I think most people told me that. Anybody tell me anything different? Anything else that is interesting that you might see there? I think most people are saying 16. All right. Next one. Oh, went too fast on that one. Okay, how many people at the conference are unemployed women? So each one of these gives me a description, right? When I see unemployed, when I see woman, that tells me what circle to go inside of or outside of. I think I already showed it, didn't I? Okay. We want them to be women, so we know it's blue, but we know it cannot be in the white circle. So everything that's in the blue circle, but not in the white circle. So this one, we kind of act like that red circle is not even there to some degree, right? It's like kind of focusing on the blue and the white. We're adding the 4 and the 20 together to get 24. I think most of you are answering that. Are there any questions? Is there anybody that's like doesn't know where that 24 is coming from or why I'm picking that 24? Okay. How many people at the conference are employed women without a college degree? So they are employed, they are women, no college degree. So I think that's tells us about all 3 of those circles and where they should go. And I think most. Okay. Someone said 6, but if that was 6, I'll give you a little hint. That would be men, right? We want women. It looks like most of you are answering. So we want employed. So if it's employed, we're going to stay within the white circle. We want women, we're going to stay within the blue circle. So right away, if I'm just looking at the overlap between employed and women, I'm looking at this 8 and 11. The next thing they tell me, they do not have a college degree. So I'm looking here. If they do not have a college degree, that means they have to be this one right here. This is number 8. What are y'all saying? Okay. A few of you, I think, are telling me. Here we go. And I think this is the last one. Or is there one more? How many women are at the conference? I think this is the last one. Ah, trying to do it in my head. Okay, yeah, I think it's it. Okay, someone said 33. I think you're close. I think you just need to like re-add that. I think you didn't carry a 1 there or something. Okay. I think most people are getting it, but if we're just looking at women, how many numbers are we going to add together in here? Yeah, there are 4 different numbers in here we're adding together, right? 4 and 20 and 8 and 11. And if we add those together, I believe it's giving me 43 is what most people are saying. Questions about this one? So basically each word they're going to give you is going to tell you whether it goes inside or outside the circle. It's going to tell you inside this one, outside of this one, inside that one, or something like that, right? Ooh. Now we want to draw a 3-circle Venn diagram. We want to fill one out. So we want to be able to go from a 3-circle, excuse me. We want to be able to go from a 3-circle Venn diagram that has numbers in it, and we want to be able to pick out the sets, right? And now this is kind of going the other way. We have like the sets down here. They're telling us what they are, A, B, P, and P. And now we want to be able to construct the Venn diagram. So this, hopefully you realize there's 3 different factors here, right? Oh, they tell you right there, draw a 3-circle Venn diagram. So I want you to spend a minute. Yeah, was there a question? Okay, I want you to spend a minute and I want you to put this thing down. I feel like if we fill this thing out, it will be a lot easier to sort of answer these questions from a Venn diagram than from a table. Okay, so I'm going to give you all just a minute to do that, and I'll be right back. Okay. Let's go to the Droid cam. Can y'all see the universe? All right, someone draw 3 sets. Probably somewhere around. Something like that. Probably got to squeeze things in, but there we go. And what am I dividing it into? I'm dividing it into what? A, which is my antibiotics, my BP, which is my blood pressure, or my P, which is my pain medication. So if I do A, is that how I have it? Yep, okay. Did y'all fill it out this way or did y'all fill it out differently? Did y'all fill it out? Did you give it an attempt?
I did the way you did.
Okay, so if I want to do 8 only and it says 12, I'm hoping you put that right here, but not in any of the other ones. So we see like this A only, we see BP only, we see P only. Those ones, they go on the outside, right? They're just going in BP only, just goes in here. P. The none, where does the none go? The 2, say none. I could probably fix this up a little
Yeah,
bit.
it's 2.
So where does that go?
Dead center.
The one that says none? Dead center should be the one that says all 3.
Oh,
right?
shoot, my bad. The box.
Yeah, so this should go in the box, but outside all the circles, the ones that says all 3, that's 20, right? And then there's a few other ones that there's the combinations. The A and BP only says 15. So between A and BP, those 2 medicines, this one. A and P only means I'm taking A and P only, but not my blood pressure, which is the 24, which goes here. Hopefully you're filling out some sort of Venn diagram that looks like between them. Am I missing something? No, there's 8 options here. Why was I was counting 7 a while ago? That would make sense. I said the counting principle applies. I was confusing myself. And everyone else is probably like, yeah, you see it. So if you look at the table, there are 8 different options that has to do with it's either in or out of the circle, and it's either in and out of the circle 3 different times, right? Or 2 to the third, 2 times 2 times 2 is another way we can sort of look at this. So back to, oh, let me share my page. So this is what your Venn diagram should look like from that table. Getting the information from the table, filling out the Venn diagram from it. So you should be able to do that hopefully by yourself. And then the next thing, let's go back to quizzes. All right, and this is the same thing. Should be the same, maybe a little bit different orientation. I think they turn theirs with their P. They do 2 on top, 1 on bottom. So they shift around the orientation a little bit, but those numbers should be the same that we had on our other one. So now we want to answer some questions. What's going on, chat? For B, it means one or the other, but not both. It can be both. If we say or, it's the inclusive or. That's a good question. So how many patients took pain medication or blood pressure medication? Okay. So what numbers do I got to add together there? It should be higher than that. What are you doing? Yeah, I don't know how to add it right quick. What are y'all saying? Someone said 115. That's close. Mark adding this. Okay. So do I include this number right here, this 22? Is that someone that took pain medicine or blood pressure medication?
They took the pain medication.
They took pain medication, so I should include this one. Should I include this one? This 24 up here?
Yes, because it's a circle.
Yeah, anything in the circle. So anything in the pain circle, anything in the blood pressure circle. So there are a total of, I believe, 6 different numbers we want to add together here. Yeah, I'm getting 105 when I add these 6 things together. Did I do it? There, did it. So it should be those 6 numbers. And one of the things people do is they will like add these 4 numbers and then they will add these 4 numbers. Sometimes people end up adding the middle section twice. And so it's going to come up in the future, but sometimes when we add 2 things, we have to subtract what they have in common. Because when you add this and you add this together, you end up adding these 2 twice. If you don't pay attention, right? You might end up adding this too many times. Questions about this? So it's everything within the P circle, everything within the BP circle, and everything that they have between them. How many patients took blood pressure but not antibiotics? Okay, so this one I think might be a little bit quicker. A little bit. Some people answering. I'm getting a few. Yep. Okay, so I think most people are getting this correctly. But if we want to look at took blood pressure, so BP but not A, right? So everything that's within this BP circle, but we cannot go within this A circle. So right here, this 8 and 16 should give me the 24 that some of y'all are answering with. Okay. Questions about this? Do you understand why it's these 2 numbers over here? So these both are taking blood pressure, but neither one of them are taking antibiotics. And one of these is really weird. They're like, how many people are taking? It's a really weird question that like is only going to exist in math class, but it's a really. Oh, no, too quick. Sorry. How many patients took at least blood pressure medication? So at least blood pressure. So what do they mean by that? Let me do it right quick.
If they took their blood pressure, it doesn't matter if they took painkillers or antibiotics.
Yeah, exactly. So does it include this 8?
Yes.
Yes. Does it include this 16, this 20, this 15?
Yes.
Everything in this circle, right, is what we want to add together. So I know I clicked it real quick. There's a few people telling me, I think the correct solution. Man, this thing, I don't know why it's, I guess I got to hit this green. That's what I got to do. I got to hit the green part down there. That little toolbar is just, I didn't know. You got to hit the green part for it to pop up. So those four numbers, we add them together, we should get 59. And then I think we get one last problem that is like, this is, I feel like this is one of those questions they're only going to ask you in a math class, maybe. How many patients took only pain medication? No, there's an F, isn't there? There's another one after this, I think. This says how many patients took exactly 2 or something. It is a really weird question. So how many patients took only pain medication? This one, I hope it gives, like, it should take you one sort of second. They're asking you about a very specific area. And this is one that, like, you could probably even go look at back at the chart, and it even tells you, like, pretty straight up, right? The number that we're looking for is the 22 right there. Yeah, there's one more after this, I believe. How many patients took exactly 2 medications? Someone told me 45. You might want to recheck that one. I think you're doing the right thing. I think maybe you just messed up on the adding. 55. 55. All right, so I think most people are chiming in with the correct thing. This is a really weird question, but we're looking at the overlap of just 2 circles at a time. So 24, 15, and 16. Those would be the people taking exactly 2 medicines. Not 1 medicine like these out in here. Not 3 medicines like the guy up in here. And not no medicines like the guys way out in here. So 55 is the last thing. Okay, so that is the end of the lesson. We are right at time, I believe, anyway. 4:19. We got 1 minute. I think someone even did better than I did. A few people did. Here's some rankings. Congratulations. You have survived another class. Are there any questions about anything we've done? So I don't know how to say this nicely, but you got to ask some questions if you don't know what's happening. This stuff is going to build on itself. Stop share. I'll still record a little bit. We are in 1C. We're doing Venn diagrams. We're going to use these things to talk about analyzing arguments in the next section. So this is building on itself. We're going to put propositions inside of Venn diagrams to do arguments, basically. Did I do like, I did this. I hope I did this in the notes somewhere, maybe. In the Venn diagram section, do they give you something like this? If A, then B, how to draw a Venn diagram that looks correlates with that. If they don't introduce it in 1C, they do it in 1D. I don't remember where they introduced it. Or if P, then Q. Venn diagrams look like for if-then statements? Is that something that we talked about in 1C? Don't remember that in 1C.
I don't remember.
It might not come up until 1D, and I'm not sure if they say it right either. Subsets. If we want to represent like this sort of statement as a Venn diagram, P is a subset of Q is another way of saying this. If P, then Q. So that is coming up. That is kind of where this is leading. And then we're going to put X's to represent members within those sets, and then try to determine whether what is being said is valid or not. So we talk about validity in 1D, talk about inductive and deductive reasoning. It's a good section. We get to wrap things up, so to speak, and apply the stuff that we've been learning a little bit.